Hey everyone, I'm Greg Arnette, co-founder and chief product officer for CloudTruth. It's ironic, I'm recording this talk the day before the US income tax deadline, and my topic is how this hidden friction in deploy processes acts like a tax on your release velocity and uptime SLO. So in the spirit of everyone likes lower taxes, let's dive into exposing where this config sprawl tax comes from and how to give yourself a tax cut. First, a little bit about me. I'm a multi-time cloud SaaS CTO. I've created numerous public SaaS instances on top of AWS and other clouds. I've experienced the pain firsthand how configuration management affects uptime SLOs. In the last couple of years, I've been working on a project called CloudTruth, and that's a build upon work I've done in this area around CF Engine, Chef, Puppet, Ansible, as well as Terraform and CloudFormation. So I have a lot of experience around this concept of configuration management. And CloudTruth represents some leading edge thinking that the founding team has brought forward in terms of ways of managing config in a different fashion. So why is this topic important? I'm just going to bring up a couple things from the headlines around how uptime SLO suffers when configuration management is behind the scenes causing problems. So even organizations as sophisticated as Google and Facebook suffer the occasional outage caused by a misconfiguration, whether it's at the networking layer, the software layer, the cloud layer. Configuration plays such an important role in everything we do in the cloud and modern IT. Just in the past year, Facebook suffered a 6-hour outage that affected 3.5 billion users. So it's a staggering kind of ripple effect. We examined countless public RCAs and found too many examples to the effect of, in the RCA, quote, the configuration was incorrectly applied to a larger number of services than intended, end quote, meaning some change was rolled out prematurely, untested, or incorrectly, and had an unintended ripple effect. And so that's how this concept is really important around thinking about SLOs and uptime. There's other ancillary problems around here. There's a lot of data loss related to misconfigurations around databases and cloud buckets. And, the governance is getting better, but it has a long ways to go. As well as rotating secrets. When there is an issue, configuration involves secrets management, and rotating secrets is one of the fun things, that we have to go through typically at a moment's notice. And I should also mention not only LastPass, but Circle CI joined the club as well. Unfortunately, we do feel sorry for what that team had to go through in terms of resolving that issue. But what we do know is that when there is a misconfiguration as the root cause, typically it's 75% of the time. And what this last breach highlighted is really the inflicted pain that all the customers of these services have to go to when they have to rotate their secrets very quickly. So let's explore how configuration is getting more complex. And it's this concept of, the 3 Cs, exploding configuration, complexity, and chaos. Today, this represents sort of what a lot of teams are dealing with. There's lots of sources of config on the left, whether it's your parameter stores and secret managers and infrastructure as code state files or repos. You have configuration stashed everywhere. And then you have all these consumers of configuration, your container orchestration, your IAC tools, your app config, your CI/CD. There's thousands of config settings everyone's touching, on every deploy. And so you have many teams operating in parallel, pushing forward on many projects and deploying to many environments. And it's a lot of complexity. And this is where this friction comes from. And there's a lot of examples of homebrew tools that are trying to fix this, and they do an admirable job, but the ROI often isn't there in the long term to maintain a homebrew tool when you can get some other things off the shelf or combine together open source projects. So taking a step back, we're all trying to strive for this virtuous cycle. And this is, the beauty of the modern DevOps movement. New ideas can get into front of customers in the fastest that we've seen really in, modern IT. But there's a messy reality here. And it's the fact that behind all these logos and services, and not every customer uses every one of these things, but every customer has a couple, 2 or 3 of them in each quadrant. There's a lot of config, and that's what's slowing people down. And so it's an area to take time to take a look at this and how it affects what's going on with keeping your uptime SLO as healthy as it can be. So where we see this specifically happening within sort of a traditional SDLC workflow where you have your requirements gathering on the left and then your maintenance mode on the right, there's this messy in the middle, code, test, deploy loops. And app dev teams touch this. They experience a lot of toil, as well as the DevOps, DevSecOps, and platform teams experience a lot of toil. So I'm not going to read all the bullet points here, but you can just get a sense of, app DevSec has to deal with rotating secrets and change tracking, and app devs need to make sure that they're available to help with dealing with escalations, as well as pushing forward new functionality. And everyone's touching config, and mostly in a haphazard fashion. So let's have some context. My co-founder and I researched this project or problem extensively, talked to over 1,000 DevOps leaders, and came away with some epiphanies around what common misconfiguration patterns teams are suffering from. And that's what I want to talk to right now is the 5 types of misconfigs that really interfere with a good uptime SLO. And so they're called duplicates, incomplete, linked, cloned, and bad values. So I'm going to go through those one at a time and keep things moving along. So duplicate parameters or secrets. This is a problem that we see all the time. And it's because that teams are using kind of a haphazard approach to organize config across, say, branches and repos and JSON and YAML files, and then stashing some values in parameter stores and secret stores. Duplicates will proliferate, and then an inconsistent naming scheme makes it harder to troubleshoot. And especially onboarding new people to the team, config management often is a black box that no one wants to touch, or it's a spring box that's going to explode if you touch it the wrong way. So how to avoid this? You can think about some concepts around centralized config that has sort of a metadata layer around all your config so you can understand if there's duplicates and then resolve those issues. But to the extent that you can avoid duplicating config, that's going to help you a lot in terms of a more stable platform. The second misconfiguration is incomplete. And this is around this idea that an existing app perhaps has some new functionality which requires a config setting behind the scenes, and the app dev may have not registered the config setting with the DevSecOps team, so it comes time for deployment. There's going to be a mismatch and just a sprawl and toil around that. So it's really around the coordination between all the different stakeholders that touch config, whether it's application developers or platform team members or security ops, to get on a common kind of page around how data is going to be named and organized, as well as workflows to promote, like when new configurations need to be rolled out, that they're complete from the get-go. Linked is another misconfiguration type. And so this is an area where in terms of you have values that are linked together in some fashion. So an example might be the DevOps team is scaling up the number of containers, but also needs to scale up the number of database instances to handle the increased load, forgetting to consider that these two values are linked in an operational sense will cause instability down the road. So a way to avoid this is you can have a metadata layer that acts as an expert system, and it can have the rules and logic programmed in. So it can be your catch-all to understand that when containers increase, database instances increase. This concept of interpolation can help also. And that's where the idea that parameter values are linked to other parameter values and can change in concert in some ratio, for example, and some logic layer applied across of that, on top of that. Clone values, another misconfiguration type. This is an example where, say, you're deployed in AWS across a US region, and then you need to deploy into the EU region. Maybe GDPR requires this. So you're going to have some environment-specific config to deal with, as well as the subtle differences between config values between, say, a US and an EU region. And so keeping things partially in sync is going to have a lot of downstream negative effect. And a way to get around this is, think about a hierarchical environment management capability that uses the DRY principles of don't repeat yourself. So you can have common values that go across multiple environments, but then have the ability to do overrides and track those overrides when the value is different, say, between an environment of production in EU, production in US, or even your dev and staging environments that need to be somewhat similar to each other. And then bad values, it's another misconfiguration type. This is actually one of the most common ones. And a typical scenario is an engineer makes a typo or an uneducated mistake editing a YAML or JSON file, and that causes a ripple effect. And the value might been a numeric or something that should have been a string, like what an integer was typed in. This is especially problemsome when you have config that relies upon JSON YAML files across repos. And it can ripple effect in terms of causing outages and security instances or excessive cost. We recently heard an example in our survey. A junior DevOps person mistakenly was editing the value of a cluster size, number of nodes, and was intending a 3-node cluster for test, but unfortunately he spun up a 33-node test cluster, ran for 30 days unnoticed. It was quite an expensive mistake. Config management doesn't directly deal with cost management in the cloud, but it plays an important subsidiary role because you have to have good configuration management in order to get a good cost posture. So that's the 5 misconfiguration types that we see so much. Now I want to talk about 7-factor config, which is a set of principles that describes a way of managing secrets, parameters, and templates that, when followed, enables teams to reliably deploy, quickly scale, and reduce unplanned downtime and security incidences. It's not prescriptive around a specific named open source tool or vendor, but rather should function as a set of best practices and a checklist that you can use internally to see how close or adrift you are from these 7 factors. And these tie into, as you would expect, the idea that the 7-factor config principles would deal a lot with the misconfigurations, the common misconfigurations that we found during our survey work. Because if we can find patterns to get around that, we'll all be in better shape. So the first of the 7-factor config principles is keep your config dry. It means don't repeat yourself. It's pretty self-explanatory. The opposite of dry is wet. Write everything twice, which means you're going to be chasing down variables and parameters and secrets all over the place when you need to make changes. But if you use a hierarchical approach, like say the Hiera database and Puppet is a great example of that, or creatively key name your secrets and store it in AWS Secret Manager or your parameters in SSM, you can kind of get to that equivalence and have a much easier time of managing config. You want to keep your config decoupled. And that first means don't make it as part of your source or inside of the source, externalize it from source. Store it alongside in a repo or organize it in a parameter or secret store. It allows you to have independent code changes from configuration changes. And it also makes it easy to isolate root causes when you know if it's a code change or a config change. And it also supports the idea of being able to frequently change config without having to alter source. So keep your config decoupled from source. And kind of connected to decoupled is abstracted. So you want to separate how your code and your configuration interact. So an example might be there's always a setting for log level. And then there's the various ways that any other service can fetch or interface with that value, what the log level is, info, debug, verbose. This allows the notion of the separation of separation of concerns. And it creates an implicit communication channel between your app devs and your DevOps team. So if you build the right systems, you can have the app devs can be making a change, and then ops automatically sees the change, whether it's traveling through the source code, workflows, or some other system that's sort of observing and writing herd around all configuration. Centralized config. This is a big one. This is where you think about those dimensions of configuration complexity, like deploying to multiple environments, not only in dev, staging, prod, multiple versions of production, geopolitical regions being deployed to. And then you have all your projects. That's another dimension. Microservices, your third-party SaaS tools, your open source tools that are being deployed to all these environments. So environment dimension and project dimension are areas where configuration gets complicated. If you can centralize that complexity, then all your client consumers of config, every single script, every single app that launches that has to get their config. If you can make those super simple, then you're going to reduce your config tax a lot, because that all the clients are really easy to understand, and it makes it easy for them to fetch their config when you consolidate that complexity. You want to make your configuration obvious. This will help new team members understand how to get up and running faster. Config won't be that big, mysterious black box that only the team elders know about, and you're relying upon the oral tradition to share the knowledge. And it also helps you understand the impact that when you're making a config change, what other systems are going to be impacted. So you think of that as blast radius. And keeping your config obvious means it's organized, so you can drill in and drill in and out and see config at a high level and drill into a specific Lambda, specific instance, a specific EKS cluster. It's just a way to have a purposeful mindset notion around keeping things organized as it relates to config. Don't need to say much about secure. Obviously, secrets need to be very, very secure, and non-secret config, like things like cluster size and cache sizes and log levels. One could debate whether these just can be plain text all the time, no problem. It's easy to troubleshoot. But you can mix and match secrets and non-secrets in an elegant way that provides the best of both worlds. And you want to keep your config versioned. So this allows the SecOps teams to get their change reports, the triage team to roll back changes very quickly as it's config related. The understanding of how config is evolving across the organization, how you're tuning your clusters, how you're tuning your system. If you keep version config, that's then has this sort of DVR capability to replay changes and then correlate that with other things going on in your environment, it gives you additional observability capabilities. So we think there is a better way by following 7-factor config, and it's going to help keep your uptime SLO in good shape and increase your release velocity. So you check it out at 7factorconfig.org. Thanks so much. I hope you found this presentation helpful and look forward to engaging in the chat.